Hey guys, this is a follow-up video on Dr. Hefner's lesson on sound intensity, where he talked about power area. So he had a diagram like this on the board, and this is a source emitting uniform spherical waves. So this could be a speaker, it could be anything that emits sound, okay? So what he had is, because this is a spherical wave, first of all, he had that the intensity was equal to the power of the source divided by the area. And because this is a spherical wave, well, these are spherical waves, the intensity was power divided by the surface area of a sphere, which is 4 pi r squared. Now I want to show a relationship between these two intensities at these two different radii. So first of all, we have the power source. Then we have the intensity, let's call it I1, at distance R1. And then lastly, we have the intensity I2 at distance R2. Okay, so what if we wanted to find a relationship between those two intensities? Well, you can do something very simple. We are going to use this equation. We're going to build one for intensity 1 and one for intensity 2. The reason why the P, just P, is because the power source is the same for both intensities. Well, to compare, we can divide the left side and the right sides, and then we'll cancel, and we end up with the following. Hopefully you won't find that algebra that complicated. In this, it's a useful, important equation, because that one compares intensities at two distances from a source without needing the power of the source. So make sure you write it down, because it'll help you with your quest homework. Okay, now let's talk about the loudness of sound, or sound level. In the video, he mentioned that our ears are logarithmic. And the reason why he was saying that our ears are logarithmic has to do with, of course, biology, but with the equation that we're going to learn. So we can hear very faint sounds and very loud sounds. And there's an average for the lowest sound we can hear. And it's as follows. Again, this is an average for the faintest sound we can hear, and it is called the threshold of hearing. It's just an average because it changes from person to person. Okay. And the loudness or sound intensity level is measured in decibels. Maybe you've seen football or another type of sporting events where they have a big screen and it's measuring the loudness in decibels. And we're going to abbreviate decibels like this: lowercase d, capital B. And there's a formula that we need to know, which tells us the sound intensity level in decibels for a sound of intensity I. Let me write down the formula. There's the formula. Let's write down what each of these variables mean. Oh, this is the Greek letter beta. Beta. So beta is the sound intensity level in decibels. I is some intensity, whatever intensity we're looking for. I naught is the threshold of hearing, which is this number. And because this is a logarithm, we can solve for this intensity, because a lot of problems ask you to find the intensity, right, based on some parameters. So let's solve for intensity. The first thing we got to do is divide by 10. We got to get rid of this 10. So then we'll have, and then I'm trusting you remember the rules of exponents. And I just multiply times I naught, and we end up with this formula. And that one will give us the intensity based on the fact that we know the threshold of hearing and the sound intensity level. Let's box the important equations for today. And there you have it.